Good morning, welcome all. Today we are going to discuss a session on Introduction to Embedded Systems. So the learning objective of this session is at the end of this lecture you should be able to outline what is meant by embedded system, give examples of its application and its benefits, and we will discuss briefly on the attribute of embedded systems and outline the constraints on embedded system including their impact. The outline of today's sessions are the introduction, characteristics, application areas, classifications, option for building embedded system, benefits of embedded systems, embedded system functions, attributes, the microcontroller hardware software for concurrency, and finally we'll end up with embedded system constraints and their impact. Let us start with an embedded system. So what is an embedded system? So embedded system is something like it's an application specific computer system and which build into a large system. And basically why we need this large system, large computer system. So because for better performance, to get more functions and features, and to reduce the cost, and similarly to introduce the dependability. And if you see the economics of this embedded system, basically the microcontrollers are used for building the embedded system, or sometimes it is known as embedded computers. And so the recurring cost is very less compared to the other high-end embedded computers, and the non-recurring costs dominated by the software development. And basically the embedded systems for certain applications uh, will be use multiple processors communicating across a network to lower the parts and assembly cost and improve the reliability. And wireless sensor applications, etc., we will be using a network of embedded systems, and especially IoT kind of applications. And as we discussed, embedded systems are application specific computers, and there are certain applications you can see in the figure, like digital cameras and gadgets such as mobile phones, smart headsets, printers, and most of the automotive systems. So where we will be using embedded systems. So most of these embedded systems are providing better performance, more functions and features. If you see the embedded environment, so there will be an input environment, and there with the help of sensors and actuators will be reading the inputs, and the embedded computers which consist of hardware as well as software component, and there will be user interfaces will be there to interact with the user. Sometimes it will be a display, sometimes it will be a keyboard, etc. And there will be provision to link other systems. The it may be a combination of different system, so there are interfacing options will be there to link to other system. So finally, after doing the operations, so we'll be getting or maybe we'll be getting the output, or maybe output to the environment. In different cases, the output will be different. For example, a audio system produces the output as songs or maybe some kind of audio information, and printer will give you the printed information, etc. Most of the embedded is something like, as we mentioned, it's a combination of hardware and software, and which is generally used for dedicated applications. And there are wide variety of applications are available across various industries. So you can see industrial robot, satellite GPS receivers, digital cameras, and various kind of music players, including your DVD players, MP3 players, etc. And there are household accessories such as microwave ovens, and then various smart devices which is used in home applications, and then high-end photocopiers, gaming consoles, set-top boxes, and wireless routers, etc., are examples of embedded systems. So the characteristics of embedded systems are something like, generally it do a very specific task, and the limited resources. So it will not be generally having the high memory and large displays, etc. Again, it depends on application to application, but generally it is very limited to limited resources will be utilized for developing this embedded system. And another characteristics of embedded systems are something like, it has to work against some deadline. Suppose it is a real-time applications, so in such cases it has to work, it has to follow some deadline. And there are actually constraints are there, because some of the embedded devices are battery operated devices, so generally the power consumption is very less, and again the reliability should be really high, and some has to operate in extreme environmental conditions. Some cases we need to operate at an outdoor environment, and some cases we need to operate at a different you know environmental condition where temperature is really low or sometimes really high. And after all, the cost sensitive, because based on application the product cost should be nominal. So these are few characteristics of embedded systems. And there are various application areas are there for embedded system. It's not limited to these, but still these are the large application areas, such as medical electronics, for example patient monitoring system, surgical equipments systems, diagnostic equipment, imaging equipment, electronic stethoscopes, etc. These are few application area under medical electronics. And similarly for remote automation application, like IoT, we have the building automation and monitoring the the weather conditions, home automations, utility meters, etc. are under the category remote automation application. An industrial control application which consists of smart sensors, special purpose controllers, networking related applications, and process controls. Coming to automotive electronics, there are electronic control units like ECUs used in chassis, body electronics, security purpose, and powertrain, and in-vehicle entertainment, infotainment systems, etc. are used generally, embedded systems. If you come to the military and aerospace, satellite systems, radar, sonar, various kind of navigation equipments, precise weather, monitoring systems, flight control system, aircraft maintenance and management systems, etc. are under the military and aerospace. Coming to telecom and data communication, routers, switches, bridges, cellular phones, smart devices, and networking gateways. So these are another category of applications. Coming to the last two categories like automation and consumer electronics, so like your fax machines, MFDs devices, multifunction devices, and post machines, etc. example of automation. And under the consumer electronics, there are many gadgets, the smart gadgets nowadays we are using, and similarly the various navigation equipments like GPS receivers and home appliances are certain application under the consumer electronics. So these all are the major application areas of embedded systems. So typically we take an example of an embedded system. We take a gasoline automobile ECU. There are various functions are there as part of the modern cars. So as many as minimum 1000 plus sensors and actuators are connected, and there are many ECUs are available. Like the functions of the gasoline engine, such as fuel injections, air intake settings, spark timings, exhaust gas circulations, and similarly the throttle control, knock control. These are certain functions of this automobile engine. And then there are as part of converting it as a smart, there are many inputs and output units as required. So there will be a lot of analog and digital sensors will be there, and there will be a lot of actuators are part of it, and then network interface to the rest of the car. So there will be different type of networking is done to connect between all these sensors and ECUs. So like CAN is one of the oldest network, and then automotive Ethernet is another kind of networking in modern cars we are seeing. And then generally they use the high performance microcontroller. It may be a 32-bit or 64-bit, etc. And but the with a minimal 3 MB flash memory for loading the firmwares and RTOS, etc. And generally it works at a low frequency in between 150 to 300 megahertz. But one of the major constraint of this typical embedded application for automotive is something like the reliability in harsh environment, because basically under the ECU there will be the temperature variations will be different, and again the cost, the total cost of this uh, product should not be increased. Once you add the embedded system into it, the net cost should not be increased, or the total product weight should not be increased. When you are adding a sensors and actuators, it should not affect the the total weight of the system. So then there will be design considerations need to be done for if these constraints are really affecting the performance of that particular automobile vehicle. So these are certain constraints. Okay. Now coming to the classification or broad classification of this embedded system. See, this classification is based on either we can do the performance and functional requirement, or sometimes it is based on the performance of the controller what we are used in the embedded system. So basically the performance and functional requirement is classified into real time, standalone, networked, and mobile. And similarly, based on the performance of microcontroller, it can be classified into small scale, medium scales, and sophisticated. And coming to the first four categories like real time, standalone, networked, and mobile phone. So the real time is something like which need a system which it has to the work has to be done in a specific time bound or maybe specific time period. So basically the real time embedded systems are classified into hard real time and soft real time system. Like for avionic kind of applications where the response time should be really perfect, and or similarly in the the missile tracking system, etc. So the timing constraint is really high in these scenarios. If we are missing the timing constraints, it will be catastrophic, and there will be the system failure will happen. And similarly there are soft real time and systems are available such as your DVD players, etc., where the deadline is there but still it is not hard as compared to the aircraft system. And if you see the another category like standalone applications, so where most of our gadgets such as the digital cameras, video, gaming consoles, and similarly the home appliances such as microwave ovens, etc. In this standalone scenarios, so there will be some scenarios like there will be the input is something like human activities. So there will be using the push buttons, or through the touch scenarios we will be giving an input, or sometimes it will be taking from the sensors, associated sensors it will be reading, and that will be taken as an input. And finally the firmware it will be processing it and it will be giving you the output. If it is an audio system, means you will be getting the audio songs, or sometimes if it is a kind of a remote monitoring system, means you may be getting onto the screen, a small touch screen or an LED display will be available. So basically the standalone scenarios are used in process control and automobile, and similarly there are electronic gadgets. These are certain applications. Coming to the networked category, so basically this embedded system that are provide network interfaces and that can be accessed by networks. It may be a wired and wireless. So like modern IoT is a kind of a good example for a networked application. And similarly, there will be wireless sensor network applications, and similarly networked process control system or web cameras connected to internet. We are accessing via internet, and similarly home security applications, etc. So where the device or maybe the system can be accessed to via network. It may be through TCP/IP or maybe a third party wireless network like Zigbee, the LoRa, etc., etc. So this is a typical an application where IoT system, where your embedded systems, we sometimes call it as a things, right? So the sensors, actuators, and wireless connectivity solution will be integrated inside the things. So sometimes we call it as smart gadget. Will be generally connected to the local network, Wi-Fi, Zigbee, LoRa, or industrial networking, etc. Like it may be a wired, wireless, power line, etc. And then there will be a gateway, will be there, associated gateway, and through this gateway it will be transferring to internet, and the servers, and the remote environment will be available, so that the dashboarding solution will be available. People can access the things remotely. So this is a kind of a network embedded system application, a good application, and it is popular in the modern scenarios. And another smart gadget which generally everyone holds, we call it as a portable devices. So these are the pictures you can see. A different style of mobile phones are available with size, and similarly the display capabilities, etc. So we sometimes call it as a smartphone. And then another category coming under this mobile scenario is something like our digital watches, or the smart bands, etc. Also tablet PCs also coming under this category. We call it as a portable embedded devices. And as I told, another way of classification is of embedded system is we can classify based on the controller complexity, small scale, medium scale, and sophisticated. And in small scale, generally the devices will be operated in battery, that is low power battery operated devices, and generally the size also will be minimal, so that it will be generally designed with 16-bit, 8-bit, nowadays even 32-bit microcontroller like ARM Cortex microcontrollers are used for designing this small scale embedded systems. And it can be developed using a single programming tools. You don't need any high end programming environment is required, but still there are compilers, cross compilers are available, and many small open tools will be available for developing application. And like the applications which we are seeing on the smart bus ticketing system, or any water tank monitoring, level monitoring systems, etc. These are example of a small scale. And coming to medium scale, and again here what happens, the 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 number of sensors, actuators will be more compared to the previous one. As you can see, the washing machine, there will be a lot of sensors will be available, like water intake, and similarly how much amount of the weight, or maybe the different levels of your dresses for detecting purpose. And similarly there are various modes are required, speed mode, and similarly the, the caring mode, etc. So there are many modes are available in your washing machine. So in such cases, like the number of IO will be more, and sensors will be more, and similarly the programming complexity is considered with the previous the ticketing machine analogy. Here it will be much more. And then there will be the the creating this application purpose, there will be different tools, like the displays are required, so sometimes you may need to do the C and C++ combinations. Certain times you need debuggers, and similarly simulating environment, IDs, etc. are required for as a developer point of view. And like there are again the medium scale are also developed with 16 or 32-bit microcontroller, but sometimes no, so we need the some minimal mathematics and the graphics processing is required. So generally it comes with a co-processors like DSP co-processor support will be available for this microcontroller. So the complexity is considered. The small scale is less complex, and medium scale is bit more complex. And then coming to the sophisticated embedded system, so here the sometimes the response time will be really very important, and like our the aviation application, flight landing gear systems, and the car braking systems, and similarly for anti-aircraft gun for military applications. So the response time is really limited. So in such cases, to increase or improve the response time, so along with our microcontrollers, so people will be using the ASICs and FPGAs, or scalable configurable processors are required. So what will happen? The complexity will be really high, and the programming language which you are using for developing the ASICs and FPGA, C and C++ may not be enough. So we have to go for the hardware descriptive languages. So and again there will be combination of hardware, not only a single FPGAs. There may be FPGA and microcontroller combinations are required for the final development of this typical product. And if you want to start building the embedded system, so we can say like here the consideration which you have made, the implementation, design cost, and similarly the unit cost, and the bug or maybe the fixing of bugs, the total size, weight, power, and similarly the system speed are considered for the uh, explaining the different options, hardware options. And there are basically we can classify it as a dedicated hardware, and similarly the software running on a generic hardware. So there are two combinations are there. The upper portions are generally we call it as, it may be a discrete logic or maybe an ASIC based design or an FPGA or PLD based design. And coming to the discrete logic, the design cost will be really less, and then the bugs fixing will be really hard if it is a discrete logic if you are using, and the total size is large compared to thing. And then whenever the size is increasing, the weight is also high, but the system speed is really fast, extremely fast we can say. And the case is same as for ASIC and as well as for the FPGA. But when it comes to the FPGA, the design cost is less compared to the ASIC, and the unit cost will be modern, and the bug fixing and all these things, FPGA is compared to the ASIC and discrete, the bug fixing will be bit easy, and the system speed is the fast, not extremely fast, it is fast compared to the the microcontrollers. And coming to the software running generic hardware, because in dedicated hardware, so the logic itself is implemented over there, but when it comes to the software running on hardware like the embedded PCs, microcontrollers, and microprocessors with add-on peripherals, so these three combinations, the design cost is very low compared to the other the dedicated hardware, and similarly the bug fixing is also very easy, and the size is not very large, it is a medium to small to medium, and the weight is the it's a medium, and in some embedded hardware, so we will be having bit more hardware combinations are coming with, weight will be more moderate to high, and the response time is considered it is fast, in embedded pieces are really fast, but microcontroller with peripherals, the clock frequencies are not very high, so that the slow to moderate will be the response, or maybe the system speed. And power consumption will be medium, not very minimal, but it will be medium, and in some cases it will be really high if it is a sophisticated applications are running. Now, what are the benefits of this embedded system? So generally, greater performance and efficiency. So that is one of the very important thing. So basically, the software make it possible to provide the sophisticated control. So you will be able to design and develop the algorithms, and this algorithm can be finally ported to your hardware. So then the next benefit is like the cost. So basically, the less expensive component can be used. You can reduce the cost, and manufacturing cost is reduced. And similarly, the once you introduce the embedded system to your application, so the maintenance cost will be really less, and similarly the operation cost can be reduced, because otherwise you need a typical human efforts can be reduced, so that the total operating as well as the maintenance cost can be reduced. And after introducing the embedded system, so you can add more features. Suppose if it's a man operated system, when you are adding an embedded system for automating it, so many possible or practical approaches can be introduced, so that the features, that the total product feature can be increased. And again, once you introduce the embedded system, so better dependability. So basically, adaptive system which can compensate for failures. So that is very important. And again, another thing, the modern automotive system. So will be we can also introduce like predictive maintenance. Okay, so that is for better diagnostics to improve the repair time. Okay, so these are certain facts related to better dependability. So these are few benefits of your embedded system. Now, coming to the system functions, so there are basically the most of the systems are the closed loop control system. It basically uses, so it monitor a process, and it adjusts an input or output to maintain the desired set point. So there are certain parameters will be used, like temperature, speed, directions, etc. will be measured as part of this embedded applications. Then another very important thing is like a sequencing. So there will be like the entire process is considered as various sequences. So step through different stages based on the environment and system. So that is the sequencing stands for. Then certain applications now, so we need a signal processing. Okay, so to reduce the interference or noises, so removing noise purpose, we need to apply the signal processing algorithm. And again, we have to filter out certain things, so that is select the desired signal features, so extracting the feature purpose, so we need to do the signal processing works as part of embedded system. Then certain embedded system, the functionalities like communication and networking, to exchange the information, and the sense information need to be forwarded for monitoring and other applications. So exchange information reliably and quickly. So that is also the one of the functionality of functions of embedded system. So coming to the attributes, so interfacing with larger systems and environment. So for that purpose, as part of embedded system, so we need to read analog and digital activities. So analog signals for reading sensors, and like temperature variations. So there are many temperature sensors are there. So many are actually converting the temperature into equivalent voltage levels. So using the analog to digital converters, we will be reading all these values, and then applying certain algorithms and identifying the exact physical quantity. So typically use a voltage to represent a physical value in most of the analog sensors. But in certain sensors, so we also will get the equivalent the current values, like most of the industrial sensors. So they will be giving you the equivalent current value. So we need to convert this 0 to 20 milliamps to equivalent voltage, and then apply to the ADC, and then further process it. And then another thing is like power electronics for driving motors and solenoids, because in order to control the speed of motor, and similarly the direction of rotation, or sometimes to start and stop these motors, so we need power electronic drivers. So this drives again need some input from the user, like it may be controlled with the PWM. So basically the PWM need to be generated from the embedded system environment. And digital interfaces, because another very important thing is like without the digital interfaces for communicating with devices, digital devices. So the simplex, in the sense switches and displays, etc. So we need digital interfaces are required. Like GPIO is a kind of scenario where in most of the embedded system they will be acting as an input output. Will be generating the digital signals. And sometimes digital sensors are there, so we need to read the digital sensor value, and instead of the analog value we need to read the digital sensor value and process it. And certain other attributes are like concurrent and reactive behaviors. So must respond to sequences and combination of events. As part of various embedded systems, so we need to read these parameters and response for these parameters, etc., as a various events, as a combination of events. And when it comes to the real time systems, so as I mentioned, so in the earlier slide we have deadlines. So it has to react in 20 milliseconds, 20 microseconds, etc., depending upon various applications. So our task has to be complete within a stipulated time. And again, the typically must be perform multiple separate activities concurrently. So we will be calling such as multitasking scenarios. So in embedded real-time applications, we need to create things that it has to create as a multiple separate activities, and we will be group that as a task, and it has to work in a very sequential manner, and sometimes it has to synchronize properly. It has to communicate each other, send data here and there. So these all to be performed. So sometimes it may need to be scheduled properly. Okay. So concurrent and reactive behaviors. So this is also one of the attribute of embedded systems. So another two attributes are like fault handling. So many systems must operate independently for long period, for long time, and require them to handle the likely the faults without crashing. Okay, so there are monitoring scenarios are required, and there are certain applications will be using watchdog timers for detecting these things. So these all facilities should be there for inside your embedded system as a handling the handling scenarios. And often the fault handling code is larger and more complex than normal case code, because it usually we don't know when this fault will happen, but whenever it happens it has to keep track of it. So the code should be really precise, and it should keep track of the fault events whenever it occurs. And another one is diagnostics, because it helps them service person to determine the problem quickly. So there will be options like certain issues happens with, so we should able to provide the information to the diagnostic service people, and it may be like updating certain information registers, or maybe as part of embedded system some LEDs, etc., we people will be keeping for for understanding the fault, or maybe keeping some short error messages in the displays, so that the service person can easily able to keep track of these issues. Now coming to the embedded system, in modern embedded system, so we have microprocessors and microcontrollers are generally used. But in many applications we can see microcontrollers are present. So if you compare both microprocessors and microprocessors, the microcontroller and processors both have the CPU to execute instructions. So microcontroller in addition has a peripheral for concurrent embedded interfacing and control. So it may be the peripherals such as analog, sometimes in the non-logic level signal, and timing concepts. There will be timers will be available, clock generators, communication interfaces, and similarly, so it will be able to use the reliability and safety. But microprocessor is considered, so it cannot work as a standalone. So it need additional, the drivers and supporting peripherals are required, and like our motherboard. So we have an Intel microprocessor is there, or AMD microprocessor is there. But along with that, there are a series of set of peripheral ICs you can see, and with the help of that peripheral ICs and memory only, it can use for a typical application. But microcontroller is something like we have the peripherals are integrated into the chip. So with a minimal circuitry, so you can develop your product using microcontrollers. So in microprocessor defined typically as a single processor core that support at least instruction fetching, decoding and executing. So that are the three pipeline, and normally it can be used for general purpose computing, but need to be supported with IOs as well as memory. So you can see the core component of a microprocessor. So we have the arithmetic logic units and register banks and instruction decoders, and there will be memory interfaces like so it will be connected to the memory blocks, and from the memory it will be the instruction fetcher will be the instruction decoder will be decoding the instruction and execute at your ALU, and will be utilizing the register bank for storing it. It depends whether sometimes 8-bit, 16-bit, 32-bit and 64-bit wide register banks will be available, registers will be available in the microprocessor application. And coming to the controller, you can see it's a combination of microprocessor plus memory. There are two type of memory. One is a program memory, another one is a data memory. And we call along with that there will be peripherals will be there, like the analog IOs, digital IOs like GPU IOs, and different type of timers, and then other peripherals such as serial ports, I2Cs, SPIs, etc. So generally the microcontrollers are a single core processor, but nowadays we can get microcontroller with a multi-core support, and typically used for basic control purpose such as embedded applications. So previously we have seen various application, embedded system application. So inside all these applications, so we can find one or more microcontroller will be placed inside that, like in digital cameras, mobile phones, your PA systems, your audio systems. In automotive, you can see many microcontroller. We call it as a small ECUs will be available. And coming to the microcontroller hardware and software for concurrency. So basically, you can see there will be a core controller will be there, and then many peripherals will be there, and there will be interconnecting all these peripherals and core. We call it as there will be peripheral buses will be available. So this CPU execute instructions from one or more thread of executions. So there will maybe a single thread of execution. Some scenarios there will be a multi threaded application, means there will be multi threads will be there for execution. And specialized hardware peripherals add the dedicated concurrent processing. So like in order to do the concurrent processing, so you sometimes, as I told, in the fault tolerance, fault detection purpose, watchdog timers were used, and then there are analog interfacing for reading the analog values, and multiple timers, and there are I2Cs, SPIs, etc. for communicating with another chips, and then there are LCD drivers. Okay, so and there are detecting external signal events. There will be many peripherals are available, and then these peripherals can work either in polling mechanism or in an interrupt mechanism. To get the CPU's attention, there will be interrupt controllers will be available. So peripherals use interrupt to notify CPU for events, detecting events. Other constraints are something like the cost is a very important thing, because as a competitive market penalized to product which don't deliver adequate value for the cost. So when you are adding the automation, it should not increase much price to the product. And again, at the same thing, the size and weight limits, because when you add a new feature, an embedded feature to your product, it should not increase the size and weight of this typical product. And most of the products are like they are used mobile in nature, like aviation, automotive application, and again a few devices are portable in nature. So if you create more complexity, not only the size complexity, but if processing complexity if you are increasing, so you need more battery power is required. So you cannot increase the battery capacity, so which will ultimately increase the weight of the product. So because mobile phone is a handheld device, so there will be a typical weight is required, so the product weight should not be increased to that typical limit. And as I mentioned, the power, so power and energy limits, because that is another most of the embedded handheld devices are like battery operated devices. So battery capacity, and again if you over increase the capacity, so cooling limits are very important. So these are power and energy limits is also another constraint for embedded system. So what is the impact for this constraints? So basically, the microcontrollers are used most of the application, not the microprocessors. So generally, it consists of all the peripherals, uh, and similarly, there will be memory or like on-chip RAM will be there, and ROM reduce circuit complexity, both complexity and cost. And if you see the programming languages, because people will be using C, like so that's why we kept an extensive C session in the next 2 weeks, because most of the embedded firmware development purpose, so we need a good knowledge, sound knowledge in the C than other high level language like such as Java and C++. And again some performance critical code maybe we will be writing in assembly. Okay, so C and assembly interfacing together we can do it. In certain embedded applications, people will be using operating system, not like a very high end operating system like Windows and all these things, but typically it will be with a small footprint like tiny OS, and there will be free RTOS, etc. So people will be using operating system. And but operating system is not a kind of a simple scheduler, so there will be the provisions will be there for adding few drivers, and there will be developing environment for creating applications at top level, and provision for multi-threading, etc. And there are foreground and background applications you can run in that system. And if OS is used, what we'll be doing, we'll be learning. You need to learn real-time operating system. Maybe in our further, you know, courses will be there for, upcoming courses are there for to learn to port RTOS on building embedded system. But as part of this session, so we'll be restricting to development in C-based, firmware development for embedded system. And building embedded system using microcontrollers, because in most embedded system, microcontrollers are chosen to be the best solution, because the low development and manufacturing costs, easy porting and upgrading or updating, and minimal footprint, and the power consumption. Most of the ARM Cortex microcontrollers are come with an ultra low power consumption, and the satisfactory performance for low end products. So whatever the experience, so the product experience are really good because the satisfactory performance are there. So that's why the microcontrollers are generally used for building embedded system. So this is all what I'm covered in the first session. So now we will be coming up with further sessions on how the embedded system can be built with the help of C programming and the hardware ARM Cortex microcontrollers. Thank you all.